gravitational potential due to a mass. Now, first of all, you have to know what is meant by gravitational potential at a point. It is something related to the work done or the energy due to a mass. So, it is the energy due to a mass, I said, but how it can be defined. So, we are going straight into the mathematical definition of this gravitational potential. It is the work done in bringing a unit mass from infinity to the point. That means, if I want to find the gravitational potential due to this mass capital M at this particular point, distance r from here, then to calculate the potential at this point, what I will be doing is that I am bringing a unit mass from infinity to the point. From infinity means no influence on this one. Okay? From no force region to the force region is coming. Now suppose that this is the boundary of this capital M, the field boundary. Then any point outside this boundary is called point at infinity of this mass. Because at those points you don't have the influence of this M coming. Okay? So these points over here are points at infinity as far as the M is concerned. So if I bring a test mass from here up to this particular point, what is the work done in that process is taken as the potential at this point due to this mass. Now remember, as you bring that test mass 1 kilogram, as I say, from here up to this particular point, no work is required because no influence of that capital M over there. But as you cross this boundary as you cross it, what happens is that this test mass is starting to experience an attractive force from this one. So at this particular point, we start experiencing an attractive force, and thereby the test mass will be gradually pulled toward this up to this one. So in that case, you don't have to do any work. The work is done by this mass here. Okay? So as the work is done by that mass, then its energy will be reducing. Let us see how it works. So if I take in between points somewhere, and the distance if I take it as x, at this particular point there is a small force acting here, and that force will be along this particular direction. And if I want to move it to a very small distance dx, then the work done dw will be equal to F into dx. Force into displacement. Okay? So, using this equation, if I substitute for dw, the force F will be equal to capital G into M into 1 divided by x square into dx. These are the mathematical steps. I am not confusing you people. And as you bring it like this, finally you want to find the total work done, that will be equal to integral dw, means I will be taking all the small work done from here to here, add it up. That small addition process from one place to another is called integration. So that will be equal to integral capital G into M divided by x square into dx from infinity to the distance r. This is what it is. Now by applying all that integration, identity is there, and finally you get that W will be equal to minus Gm by r. And this work done is called gravitational potential V. Therefore, that V equal to minus Gm by r, I could say. So, gravitational potential is negative because, as I said, here the work is done by the mass and thereby the energy is reducing. That reducing energy is given by this negative sign. Or you can say the work is done by an attractive force and therefore it is negative. Attractive force is assumed as negative force. So work done by a negative force is negative. So that is how you are taking this negative sign over. Okay? So this is the equation for gravitational potential, and I just explained how we are coming to this particular place. The integration and all will be confusing. We will be studying next year only. So let us take this result as example. Okay? So when you compare this with the gravitational field, what do you get? Field E at that point will be equal to capital G into M by R square. Yes? So to get this one, you have to multiply this with R. So relation between capital V, the potential, and the field will be minus E into R. From these two results we are getting it. But in the actual sense it must be V equal to minus of integral E dot dr to the result. Okay, so gravitational potential and gravitational field, how they are related.